Hello everyone! Today we're going to talk about more Algebra 1 topics. And we're going to talk about ratios and proportions. And I like this word proportions because it starts with pro. And this is multi-pro. And if you want to learn more about Algebra 1, please hit that subscribe right now. And if you want to see more topics of other as well, hit that subscribe button and we'll make sure that we cover the stuff you want to learn about. So today we have two different goals. One is to determine whether two ratios form a proportion or not. And we want to solve proportions. Alright, so let's go ahead and let's start with a definition. Let's talk about ratio. What is a ratio? This is a comparison of two numbers by division. So what do we mean by that? Well, we can write this different ways. We can say x to y, that relationship. And we can say y with two dots, which is a colon, y to z. Or we could just take a fraction and have like a divided by b in that ratio. Okay? So let's talk about another definition, and that's proportion. I like this. It starts with pro, like multi-pro. So proportion. Alright. So this is an equation stating that two ratios are equal. Okay? So let's look at an example. Example 1. And I'll list example numbers here just in case you have any questions. You can specifically say which example you have a question about. Or you can tell me which time of the video. And I'll try to do my best to answer your question. So we want to determine whether the ratios 1/3 and 3/9 form a proportion. Okay? So let's look at this and let's try 1/3 divided by 1. That's still equal to 1/3. Okay? And let's try to get the other proportion down to 1/3. If we take 3/9 and divide by 3, so 3 divided by 3, that's equal to 1, and 9 divided by 3, that's equal to 3. They do form a proportion. Alright, let's look at another example. Example 2. Alright. We want to use cross products. And cross products are things that you will use a lot in math, particularly in a scientific field later on, to determine whether, and those cross products may be a little bit different than what we're learning here today, each pair of ratios form a proportion. So we're going to determine the same thing, but we're going to do it a certain way. And what's the numbers that we're looking at here? We have 1/3 and we have 3 over 7. Okay. So we want to know, is 1/3 equal to 3 over 7? So what we're going to do is we're going to cross multiply. So we're going to multiply 3 times 7 and 3 times 3. Okay? So when we do that, we get 1 times 7 is equal to 3 times 3. We want to know if that's true. So this is 7 and this is 9. That does not form a proportion. Okay? So 7 does not equal 9. Alright, so let's talk a little bit about this cross product thing that we did. So, I don't know what it did. In a proportion, the product, remember product means multiply, of the extremes. Whoa, that sounds really bizarre. Extremes is equal to the product, so we're multiplying again, of the means. Oh, those sounds like some bad people. So what is this extremes and what is this means? These extremes sounds like some extremists. And these means, they sound like some bad people. Well, let's talk about this a little bit farther here. So, if A over B is equal to C over D, then we do this cross product. We get AD equals BC. And we're trying to figure out, is that true or not? So in this case, A and D, these are the extremes. Okay. And then what are the means? Well, they're the other two that are left, B and C. These are the means. Okay, so the extremes you cross multiply, and then the means you cross multiply. My arrows are not drawing properly. So you'll just have to imagine A times D and B times C. Okay? So let's look at an example of this cross multiplication and what we're talking about here. So let's say if 4 over 8 equals 2 over 4, then 4 times 4, remember we are cross multiplying, then we got to cross multiply again. These arrows are not working. Okay. And that is equal to 8 times 2. Okay. So let's see if this is true. So 4 times 4 is 16, and 8 times 2 is 16. So yeah, we're using this cross product to see if these form a proportion. In this case, we do. All right. So let's solve a proportion here. Let's look at example 3. We want to solve the proportion. We got x over 7 is equal to 3 over 1. Alright. So if we cross multiply x times 1, x times 1, draw the x a little bit better there. X times 1 is equal to 7 times 3, the other cross product. Alright, so then we get x is equal to 21. Great job! We already solved the problem. Okay, let's talk about another definition. And this one is not ratio, but rate. It's kind of like ratio. So this is the ratio of two measurements having different units of measure. Okay, so let's look at an example. Example 4. We're getting lots of examples today. This is great. Alright, so the car goes 1 mile in 30 seconds. When completing 1 lap around the track. This sounds like racing. This is my kind of stuff. If the car completes 5 laps, that is 5 miles, since 1 lap is 1 mile. How long will it take? Now we're going to make some assumptions here that the car is going to travel at the same speed and is not going to fall off any pace or gain any pace or anything like that. Alright, so what we're going to do is we need to put mile over minutes. That's not minutes. Okay, so we're going to do that here. So we're going to put 1 mile, and how many 30 seconds, how many minutes is that? Well, there's 60 seconds in a minute, so 30 divided by 60 is 1/2. So we're going to say 1/2 down here. Okay, and this is going to be equal to 5 miles over how many minutes? Because we're trying to figure out how many minutes it takes to do 5 miles. We already know it takes half a minute to do 1 mile. Okay, so we're going to do this cross product again. So 1 times x. So 1 times x is equal to 0.5 times 5. So we got x is equal to 2.5. So it takes 2.5 minutes to do 5 laps. Great job! Alright, let's look at one last example here. Example 5. And this one is very applicable to my field. We use this stuff quite a bit. So the scale of a blueprint. Let's be fun and write that in blue. Blueprint. Right? Because it's a blueprint. It should be in blue. Is 1/4 of an inch equal to 1 foot. Alright, so if you see 2 lines, that means an inch. If you see 1 line, 1 apostrophe, or like possession of ownership, kind of like if you write a sentence versus a quotation mark. The quotation mark is for inches, and then apostrophe there is for feet. Okay, we could write this as 1/4 inch is equal to 1 foot. Either way, okay? So if the distance between 2 points on the map is 3/4 of an inch, what is the distance in true scale? True scale means like in real life. Alright, so what we're going to do here is we're going to list the inch over the feet. Okay? So we're going to have 1/4 inch, 0.25, over 1 foot. And that is equal, we're looking at, alright, we set 1/4 over a foot, and we're looking at 3/4 of an inch, so 0.75, and we're trying to find out how many feet is that. Alright, so let's do the cross product, and we get 0.25 times x is equal to 1 times 0.75. So we know this is 0.75 and this is 0.25x. So if we divide by 0.25 on each side, we find that x is equal to 3 feet. So if it's 3/4 of an inch on the map, that's actually 3 feet in real life. Alright, great job. So today we learned about ratios and proportions. I can't wait to share with you the next lesson. And I'm looking forward to it. If you haven't already hit that subscribe button, please do it. See you later. This is MultiPro.